Now that you have some idea of the 5 basic logical connectives in propositional logic, the next important concept is going to be building the skill of finding the truth values of a compound sentence when given the truth values of atomic sentences within that. So let's remind ourselves of the 5 connectives or operators. We have the tilde for negation. We have the V or the wedge for disjunction, translated as or. We have the dot for conjunction or an and. We have the horseshoe for implication, also known as a conditional. And we have the triple bar for equivalence relation, also known as a biconditional. Each of these logical connectives or operators is going to affect the truth value of the compound sentence we can find them in. So for example, if A is true, then not A is false. So the tilde or the negation basically reverses the truth value of whatever you're given. We can see this reflected in the truth table for negation, which I'll repeat for you here. So if P is true, not P is false. If P is false, not P is true. What about disjunction? What does disjunction do to the truth value of a compound sentence? We can read disjunction as an inclusive or. This means that either one or both of the disjuncts must be true in order for the overall disjunction to be true. So to see what that looks like in terms of a truth table, we can look at what do the truth values of the component parts of a disjunction mean for the truth value of the disjunction as a whole. So remember, one or the other or both of the disjuncts must be true. So we can see in all 3 of these first scenarios the disjunction is true. The only case in which it's false is if both disjuncts are false. For a conjunction, it's kind of the opposite. Both need to be true. Not the opposite, but it's different in that it's not that one of them must be true, it's that they both must be true. So there's only one scenario in which a conjunction is true, and it's the case in which both conjuncts are also true. For implication, the cases where P is true must be cases where Q is also. So we can see a truth table for implication. If P is true and Q is false, then the implication is false because that would mean that P does not entail Q. If P is false and Q is true, the implication is true. And if P is true and Q is true, the implication is also true. And if they're both false, the implication is also true. So the only way in which an implication is false is if the antecedent is true and the consequent is false. For an equivalence relation, the truth value needs to be the same. So whether they're both true or both false, both of the implicata in an equivalence relation must have the same truth value in order for the overall sentence to have the truth value that have true. So there are the truth tables for each of the connectives. And if any of those don't make sense, I encourage you to think through some examples in English. Just take your time, slow down. And basically what you can use this to do is you can use this to find the truth value of a compound statement by working from the inside out. So start with the truth values of the atomics within the overall compound statement, and then use those to see if you can figure out the truth values based on the truth tables for the operators. Let's look at some examples to really walk through what that looks like. So we always want to start with what we know. Here we're given that A, B, and C are true, X, Y, and Z are false. So I'm going to start by labeling each instance of A, B, and C with a T, and each instance of X, Y, and Z with an F. Then I'm going to go through each connective, starting with negation, the negations that are inside parentheses. So this not Y here in the middle, since Y is false, I know not Y is true. Since not Y is true and B is true, then that conditional there is true. Since Z is false, I'm looking at the truth table for the conditional here. Z is false and C is true. That means that conditional there is also true. Since both of the biconditionals here have the same truth value, it's true. Opposite truth value, the other one's false. But only one of a disjunction needs to be true for the whole disjunct to be true. And both conjuncts are true, so the conjunction is true. Since the disjunction was true, the negation of it is false. But we only need one disjunct to be true. So that means the overall sentence is true. So we work outward after starting with we know until we get to the main operator. The main operator with this sentence is the disjunction there. So the overall truth value of this overall sentence is true. And I worked through it kind of fast there. I think, working through it yourself, you really want to take your time, go slow. I encourage you to pause right now on this second one and try to work through it on your own. I'm going to do it quickly. Again, starting with what we know, labeling A, B, C is true, X, Y, Z is false. Then I'm going to go through and do the negations inside the parentheses, reversing the truth values here. And the disjunction there is true because the only one disjunct needs to be true. For the conjunctions, since both conjuncts aren't true in the second one, then it's false and the first one is true. And then we're going to work through looking at the truth value of this conditional here. Since both implicata are true, then that makes it true. Since P is true and Q is false in the second one, so see the T, then F makes that F. But then, since we have a true and a false for a conjunction, that makes the conjunction as a whole false. The main operator in that one was a conjunction, so the whole overall thing is false. So this next section of problems adds an extra twist, which is that some of the propositions have an unknown truth value. Sometimes we can still determine the truth value of a whole even with unknowns. So here I'll label the unknowns with a question mark. And we also know that A and B are true, Y and Z are false. Okay, so we've got something unknown and something false. The conjunction has to be false even though we don't know what Q is, because both conjuncts have to be true for a conjunction to be false. We know both conjuncts aren't true. Similarly for a disjunct, at least one disjunct needs to be true for the whole thing to be true. So that means that we have a true and a false in the biconditional, which makes the biconditional false because they're not both the same. Again, I know I'm going through it quickly, so try to work through this next one on your own before you see how I go through it, so that you can see if you can work through what can and cannot be determined. So again, label what we know and what we don't know. P and Q are unknown. Z and Y are false. A and B are true. There's no A's and B's here. Okay, so looking at the conditional, we don't know if the first implication is true or false, but we know the second one is true. So that means that we know the disjunction. Oh, wait, no, we don't, because we have to apply that negation first, which we don't know. Okay, but still, with an unknown truth value and a true truth value, we know that the disjunction is still true because at least one of the disjuncts is true. So that negation there almost tricked me. It applies only to that first parentheses. So I encourage you to work through examples. That's the only real way to learn how to do these types of problems. Repetition, repetition, repetition. If you do it enough times, it won't even feel like you need to memorize things, because you'll just develop the skill of being able to work from the inside out to find the truth value of a compound proposition when given the truth values of the atomic propositions within it.